Here's part 5 of the series on factoring, and we're going to cover grouping in this series. You'll still need the 14.6 class notes and class practice. So far we've learned that when we first see something that we're told to factor, we look for the greatest common factor. We make sure that we're not messing up a formula that involves perfect squares before we do so. And then you look at the special cases and see if what you're about to factor has any of the special cases. If it has two terms, if it's a difference of squares. Not a sum of squares. There is no sum of squares formula. So if you have a sum of squares, then you're done. You can just say it's prime or it's not factorable. Then you ask if it's a sum or difference of cubes. There are formulas for both of those. Then you ask if it's a perfect square trinomial, and that would be in the case of 3 terms. In all of these special cases, you are looking for a perfect square in the first and last terms. Okay, once you decide there aren't any of that or you're done with that, then you look to see if anything can be factored that has a coefficient of 1 in front of the squared term. If it has a coefficient of 1 in front of the squared term, you use reverse FOIL, which we covered in the previous video. And if the coefficient is anything but 1, then you use grouping like we're about to do. Also, if you have 4 terms instead of 3, you try grouping. So on page 2 there are a lot of problems. I want you to go through those and see, let's identify together if anything can be grouped. So we are looking for a trinomial that has a coefficient other than 1 in front of its squared term. Here's one, but we've already identified this, if we've gone through the steps right, as a perfect square trinomial, and we've used the formula on it, so that isn't one we would use. We would do grouping with. Okay, number 7, that looks right. We're going to try grouping there. Number 8, we are going to look at grouping there, and number 10 would have a 1 in front of its lead coefficient. Number 11 is a perfect cube trinomial, and number 12 doesn't have any squared terms. So we're just looking at number 7 and 8. Grouping starts out kind of similar to reverse FOIL in that you draw a table. But instead of putting this number over your first column, you're going to multiply the first and third numbers and put the result in your first column. In this case, it's negative 12. Now if you think about it, if you use reverse FOIL, this number would be 1, so you're doing the same thing. You're multiplying 1 times this and putting it here. So that's how it's similar. But in this case, don't forget to multiply these two and make it over your first column. In the second column, same thing as before. You put your negative coefficient, or your middle coefficient, which in this case is a negative 1. So we want two numbers that multiply to be negative 12. That means they're going to be a positive and a negative, and they add to give us negative 1. That means the larger has to be negative, so that we add to get a negative 1. So by this point you may be familiar enough to go ahead and write down your answer. Negative 4 and 3. However, here's where grouping differs, and it's very important that you realize this. In grouping, you don't just write k minus 4, k plus 3. And look at why. If you FOIL this, you get k squared instead of 2k squared. So you'll FOIL this and you'll find out that you get k squared minus k minus 12, which is not this. So this is factored incorrectly. So we're going to ignore that. What we are going to do instead is we are going to rewrite this with the first and third terms exactly the same. So we rewrite 2k squared, and over here you're going to have minus 6. Now notice I've left a lot of room in between. Instead of minus k, you're going to write minus 4k plus 3k using these numbers. And you want to do that because minus 4k plus 3k adds to give you minus k. So it means the same thing, but it sets you up to be able to group. Now on a side note, if you have a negative and a positive here, it will be easier on you if you put the negative number first. Either way will produce the same solution if you don't make mistakes, but by putting the negative number first and always having a plus sign in the middle if possible, then you will be less likely to make errors with negative signs. Okay, once you have set this up, that's when you do your grouping. You group your first two terms by putting a parenthesis around it. Then you have your plus in the middle and you leave it there, and then you group your last two terms. And the trick for grouping is that we are going to look at the greatest common factor of this and then a different greatest common factor of this. So the greatest common factor of the first parentheses is 2k. 2k goes into both of those terms. So what's left? We divide both by 2k, and we have k minus 2 is left. In the second term, we see that they have the common factor of 3. So we write down our plus in the middle and then 3 parentheses, and what's left after we divide everything by 3 is k minus 2. So stand back and look at this expression now, and you'll see that k minus 2 is common. It's a common factor to both of these. So we can pull it out, k minus 2, and then we write multiplied to that is what's left. And then we're done. That's the last step. So when you FOIL this expression, you will get what you started with. So let's go ahead and do that. We get 2k squared plus 3k minus 4k minus 6 equals 2k squared minus k minus 6. And so when we look back at what we started with up here, we see that we have done it correctly. The next problem we're going to look at is number 8. And so in number 8, our first question is there a common factor? And we see that everything has a 2 as a common factor. It also has a z. So 2z is a common factor. And then when we divide everything by 2z, we get 14z squared plus 3z minus 5. Okay, now we go through our questions. Are there any more common factors? No. Is it a special case? No, because there are no perfect squares. Is there a 1 in front of the z squared term? No. So we use grouping. And in grouping, we set up our column, and our first one's going to be 14 times negative 5, which is negative 70. It's going to be our first term times our last term. And then in the second column, we're going to write the middle term, which is 3. So we need two numbers that multiply to give us 70 and add to give us 3. And if you look, that's going to be 10 and negative 7. So 10 and negative 7 multiply to give you negative 70 and add to give you 3. Okay, now we keep our 2z around, and then we rewrite what we had, 14z squared, and we're going to have a minus 5 over here, but then we add 10 and subtract 7, only I recommend you subtract 7 first. So your middle term, which is 3z, is going to be written negative 7z plus 10z, which is the same value. So we're going to write negative 7z plus 10z minus 5. So now we have inside the parentheses the equivalent of what we started with. And now we're ready to group. We group the first two and we group the second two, and we have a plus in the middle, which makes it easier with negative issues. So we rewrite this, not forgetting our 2z, and let's use brackets here to deal with everything in the parentheses. In the first binomial, the common factor is 7z. So we pull out a 7z, and we're left with, and then let's go ahead and divide by 7z, and we're left with 2z minus 1. In the second case, we can pull out a 5, and we're also left with 2z minus 1. Okay, so the next step, go ahead and write down your 2z, and now we have inside the brackets, we have the factor that's in common, 2z minus 1, and then we write out 7z plus 5. And you don't really need that bracket, and so I recommend in your final answer you take it off. And so your final answer is 2z times 2z minus 1 times 7z plus 5. And you can go ahead and FOIL this and then multiply through by this, and you will come up with that. Turn to your 14.6 class practice and circle everything you think might need to be done with grouping. Go ahead and pause the video to do that. Okay, you should have circled 1, 3, and 6. 2 is a binomial, so grouping won't work for it. 4 and 5 have a 1 in front, so they couldn't possibly work. And then 7 you might have circled, but you needed to ask, is it a perfect square trinomial? And it turns out that it is. And the others are binomials, so they won't work. So let's look at 1, and what I want you to do is go ahead and practice this problem using grouping. So we're going to write our brackets, and we'll multiply the first and third term and put a negative 30 in our first column and write the 13 for the middle term in our second column. And we need numbers that multiply to give us negative 30 and add to give us 13. So let's do 15 and negative 2, and when they add together they give us 13. Now we rewrite what we started with. 10a squared the first term, and the last term stay the same, but then we add 15a based on the numbers we found and subtract 2a to represent our middle term. And this sets us up for grouping. Now notice I put a negative sign in the middle, and I cautioned you to put the negative first. But I want to show you how to handle it, because sometimes you're forced, everything's negative, and you're forced to have a negative middle term. So when you have a negative middle term, you need to change subtraction to addition, which is simply add a sign, so your positive 2 becomes negative 2, and your subtraction then becomes addition. So we have 10a squared plus 15a plus negative 2a minus 3. You don't have to do that for the minus 3. So now we're ready to group. We're going to group. The plus sign stays outside of the parentheses. And in our first case, we pull out a 5a, and we're left with 2a plus 3. plus, and then we pull out a negative 1 so that we get 2a plus 3. So now we have the common factor of 2a plus 3, and we're left with 5a minus 1. This is what we hope is the solution, and we can check that easily with a quick FOIL. First term is 10a squared, outer term is negative 2a, inner term is plus 15a, so that gives us plus 13a, and then the last term is minus 3. And this corresponds with what we started with, so we've checked our answer. Okay, go ahead and use grouping on this problem and see how you do. The first question we ask is there a common factor? And in this case, let's do it the long way so that you can remember how to do this. I think we did this for this very problem on an earlier video. So we break up our coefficients into their primes. 18 is 2 times 3 squared. 24 is, 8 times 3, which is 2 cubed times 3, and 12 is 2 squared times 3. So you can use factoring trees to get that far. And then you circle each individual occurrence of the base. In this case, we only have 2's and 3's, and you circle the smallest exponent, and you only circle it once. So in this case, it would be 2 and 3. And then you look at your m's. You have m to the 5th, m to the 3rd, and m to the 6th. So you circle your smallest exponent, and now you know that your least common denominator equals 6m to the 3rd. So we write that here, and then we divide everything by 6m to the 3rd. And that leaves us with 3m squared minus 4 plus 2m to the 3rd. So now we need to see if we can factor this, and we need to rewrite it. Well, in this case we have m cubed, m squared, and negative 4, so we don't have a trinomial. So we can't use grouping on this because, we do have a trinomial, but we don't have x or m squared, m, and nothing. We have m cubed, m squared, and nothing. So we can't factor this any further. Here's a case where we have 4 terms, and the last thing we talked about under grouping is try grouping if you have 4 terms. So let's do that. It's all set up for us, except for one thing. There is a minus in the middle, so we need to change subtraction to addition by changing the sign and adding a line to the minus. Now that we have plus in the middle, let me make sure you can see that, then we can group. So we group the first 2 terms, and we group the second 2 terms, and then let's see about a common factor. In the first one, we have r times r, we have r squared actually, times r plus 4, plus, and then the last one we can pull out a negative 6, and we're left with r plus 4. So now we have r plus 4 as a common factor, and we're left with r squared minus 6. And then we ask if we can factor anything else. R squared minus 6. 6 is not a perfect square, so we don't have a difference of squares, so we know it's fully factored. Now let's check our work by foiling, and we have first is r times r squared, or r cubed. Outer is going to be minus 6r inner is plus 4r squared, and multiplying the last together we get minus 24. So if we look at what we started with, we have r cubed plus 4r squared, which shows up here and here, minus 6r minus 24. So our answer checks. And that is the end of our video series on grouping. So you should be getting proficient at all of the factoring techniques, and you can see that the key is to step back from your problem to start with and go through the steps to figure out exactly what approach to take. You also need to memorize those special case formulas and remember a couple of things. A sum of squares does not have a formula, so that means it's fully factored, and when you're dealing with a minus sign in grouping, the middle operator is minus, then you have to change it to addition by putting a sign in front of the term, changing the sign in front of the term and making the minus into a plus. And that ends the lesson on factoring.